Let's do some problem solving for equilibrium constants. So at equilibrium at 2500 Kelvin, the concentration of hydrochloric acid is 0.0625 moles per liters, and both hydrogen and chlorine are 0.00450 moles per liter. Here we have the balanced equation already for how hydrogen and chlorine combine to make hydrochloric acid. So these are going to be my reactants, what I start with. Hydrochloric acid is going to be my product, what I end with. And you'll remember the way we solve for this is the concentration of the products over the concentration of the reactants is how I get my equilibrium constant. So my product, of course, is going to be hydrochloric acid, and I need to put that squared to represent the fact that there is a 2 for the coefficient in the balanced equation. Now I'm going to take the reactants, which is going to be hydrogen and chlorine. And it's very important to note I am going to be multiplying them together, not adding them. So now I'm going to do the math right here. I'm going to substitute that in. Hydrochloric acid 0.00625 and both hydrogen and chlorine are 0.00450. So I'm going to put that in, make sure to square it, divided by hydrogen times the concentration of chlorine. Once I put that in there, now I can solve that out. 0.00391 divided by 0.0000203. That's going to work out to be an equilibrium constant of 192.61. All right, at equilibrium, a mixture of nitrogen, hydrogen, and ammonia gas at 500 degrees Celsius is determined to consist of 0.602 moles per liter of nitrogen, 0.420 moles per liter of hydrogen, and 0.113 moles per liter of ammonia. What's the equilibrium constant? So I'm going to fill in these numbers right here. Now I know that K is going to be the products divided by the reactants, so I'm going to substitute. These are going to be my reactants, this is going to be my product, so I'm going to start with the product of NH3, and that's going to be raised to the second power. Again, don't forget the coefficient right there, divided by the reactants. Nitrogen is going to go right there, and then the hydrogen is going to be in there, and I'm going to cube the hydrogen, reflecting the fact that the coefficient is 3. Now, solve this all out, and I get 0.113 divided by 0.602 times 0.0420. And remember, I'm going to square that top one and cube the 0.420. Solving that out, I get 0.0128 divided by 0.0446. Solving all that out is going to give me an equilibrium constant of 0.287. All right. Nitrogen, oxygen, and nitrogen monoxide gases at 1500 Kelvin is going to consist of those concentrations right there. What's the equilibrium constant for the whole thing? So I'm going to fill those in: 6.4 times 10 to the negative third, 1.7 times 10 to the negative third, and 1.1 times 10 to the negative fifth. There's how I solve my equilibrium constant. There's my reactants. Those are my products. So I'm going to put the products over the reactants. Make sure to square the nitric oxide. And on the bottom down there, I'm going to have the concentration of nitrogen times the concentration of oxygen. Now I can take those there, substitute in the numbers. And when I solve that out, I'm going to get 1.09 times 10 to the negative fifth in the denominator, and 1.1 times 10 to the negative fifth in the numerator. Pretty similar numbers. That's why the equilibrium constant is going to be 1.01. Here I have the reaction of hydrogen plus iodine is going to make hydrogen iodide at 425 degrees Celsius. Find the concentration of hydrogen iodide given that the equilibrium constant is this. So this one's going to be a little bit different. I'm not solving for the constant. I have the constant. Now I need to solve for some different concentrations. So I'm going to start by putting that as my unknown. But K, my equilibrium constant, is going to be 54.3. I'm going to fill in what I have for those other numbers there. Write that out, so that's going to be products over reactants. Now I can start substituting in. So that's going to be concentration of hydrogen iodide squared over hydrogen times iodine underneath that there. So 54.3 equals hydrogen iodide squared over concentrations of hydrogen times iodine, which is going to be 4.79 times 10 to the negative fourth times 4.79 times 10 to the negative fourth. Solving that out, combining those, 2.29 times 10 to the negative seventh. So hydrogen iodide squared, doing some algebra right there, is going to represent 1.25 times 10 to the negative fifth. So to solve for hydrogen iodide, I'm essentially going to take the square root of both sides right there. That's going to give me, instead of 1.25, it's going to be 3.53 times 10 to the negative third power. That is going to be my concentration of hydrogen iodide.